I think in this century, we'll probably pick up signals from an extraterrestrial civilization to learn more about the universe beyond our solar system. NASA sent the Voyager 1 probe into space in 1977. They had no idea that their tiny spaceship would go on to become one of the greatest and most exciting feats in human space travel, one that would forever mark an era in the collective imagination and inspire future generations. Its findings have widened our knowledge of the solar system's furthest reaches, and it continues to yield new insights into the cosmos. The probe's continued journey through space encapsulates human curiosity and our yearning to discover the uncharted. However, NASA's Voyager 1 spacecraft recently had an odd encounter with an unidentified space object, leaving physicists perplexed. Who or what has Voyager 1 contacted? How long will the spacecraft remain in orbit? Let's find out. A Titan III Centaur rocket carrying Voyager 1 lifted off from Cape Canaveral in Florida on September 5, 1977. Its purpose was to photograph the planet's moons and research Jupiter and Saturn, focusing on the Titan satellite, its magnetic fields, and its rings. But it ultimately covered a lot more ground than that. The spacecraft, which is roughly the size of a small vehicle, is loaded with numerous scientific tools, all of which were state-of-the-art in their respective fields at the time, such as cameras, spectrometers, and plasma detectors with the purpose of gathering information about the planets it visited. The probe was launched and spent the following 2.5 years traveling to Jupiter, where it made its first significant finding on March 5, 1979. The probe made a pass by the gas giant and continued to take pictures of the planet until April. A little while later, Voyager 2, the sister probe, was in turn. Numerous discoveries were made about Jupiter and its moons by the two Voyagers. The finding of sulfur volcanoes on Io, which had never been seen from Earth or by Pioneer 10 or Pioneer 11, was the most unexpected. The four largest moons of Jupiter, Io, Europa, Ganymede, and Callisto, which are commonly referred to as the Galilean moons, were then found to be part of a complex system of moons around Jupiter. In addition, Voyager 1 found that Jupiter had strong magnetic fields and radiation belts, which may be hazardous for any spacecraft that traveled too closely. The spacecraft made new findings while traveling towards Saturn after finishing its mission at Jupiter. On November 12, 1980, as it passed just about 75,000 miles from the planet, the object made its closest approach. The probe found that Saturn had many more moons than previously believed and had hundreds of rings, each of which was composed of thousands of tiny particles. Titan, the moon of Saturn, was found to have an atmosphere by Voyager 1, making it the only moon in the solar system to do so. Voyager 1 finally left our solar system in 2012. It then made history by becoming the first artificial object to go into interstellar space, which is the region between stars more than 13 billion miles away from Earth. Is still sending data back to researchers and revealing important details about the structure of the cosmos. Voyager's entry into this new region, where impacts from the rest of the galaxy become more obvious, was first anticipated by scientists to be gradual and uninteresting. Then the peculiar zone turned out to be far more intricate than anything they had anticipated. The solar wind, which is ejected supersonically from the sun's atmosphere at a speed of more than 620,000 miles per hour, is a plasma of charged particles. Some of these ions are propelled outward at speeds of up to 10% of light. The solar magnetic field is also carried by these particles. This wind is believed to eventually reach the interstellar medium, which receives a totally distinct flow of particles from the deadly explosions of big stars. Galactic cosmic rays are the name for the incredibly energetic ions produced in these bursts, and the solar wind mostly prevents them from entering the solar system. The magnetic field of the galaxy is estimated to be at a substantial angle to that of the Sun. Voyager 1 entered the solar wind's edge in 2003. According to research, the spacecraft's detectors showed that the particles around it were traveling subsonically after having slowed down after departing from the Sun. Then, a year or so ago, the probe's immediate environment became incredibly quiet. The solar wind abruptly decreased by a factor of 1,000 to the point where Voyager 1's equipment suggested it was almost invisible. This change happened really quickly, in just a few days. The readings of galactic cosmic rays also considerably rose during the same period, which would be just as we expected if we were outside the solar wind. According to Caltech physicist Ed Stone, the project's scientist for Voyager and the primary author of one of the science studies, Voyager 1 almost appeared to have escaped the Sun's sphere of influence. What then is the issue? Well, galactic cosmic rays ought to be pouring in from all directions if the solar wind has fully disappeared. Instead, Voyager discovered them coming primarily from one direction. Furthermore, the probe hasn't detected any significant changes in the magnetic fields around it, despite the solar particles having decreased. Given that the galaxy's magnetic field is assumed to be inclined by 60 degrees with respect to the field of the Sun, that is difficult to explain. The probe also detected the interstellar space's only signature, a weak plasma hum that researchers likened to light rain. Since 2012, Voyager 1 has been measuring the plasma surrounding the Sun as it has strayed further and further from it. Most of the time, this region of the interstellar medium is calm. The signal is very faint and monotone because it is in a narrow frequency bandwidth. However, the solar wind pushes back every few years. These occurrences are detected by Voyager 1 as shock waves. Senior author and Cornell University astronomer James Cordes compared identifying a solar outburst to finding a lightning strike in a thunderstorm. After that, it resumes raining lightly. But even for a spaceship, aging has its own set of challenges. The probe last year encountered a problem with its Attitude Articulation and Control System, AACS, the system that keeps its antenna pointing toward Earth. Without any known interference in its previously flawless record, the confused probe started sending back inaccurate telemetry data through an onboard computer that had stopped working years previously, distorting the correct data as it became confused about its location in orbit. Voyager's blunder raises the question of whether it is time to retire one of NASA's oldest and farthest traveling space probes. However, engineers were recently able to resolve the problem by instructing the system to revert back to its previous computer. Despite these challenges, Voyager 1 and its twin Voyager 2 continue their mission. The golden records aboard them, containing music and images representing humanity, are expected to last billions of years. Even as the Milky Way collides with the Andromeda Galaxy in the far future, the Voyager probes may still drift through space, holding a piece of Earth's history for any future intelligence to discover. Voyager 1's journey is a testament to human ingenuity, curiosity, and our relentless pursuit of knowledge. As it ventures deeper into interstellar space, it continues to send back invaluable data that reshapes our understanding of the cosmos. With each new discovery, we are reminded of how much there is still to explore beyond our solar system. Will Voyager 1 unlock more cosmic mysteries? Could it one day make contact with something truly extraordinary? Only time will tell. But one thing is certain, its mission is far from over, and the universe still has many secrets waiting to be uncovered. Stay tuned for more groundbreaking revelations from humanity's most distant explorer.